In this class, we'll continue our discussion of the key terms we will use throughout this semester. In the next two slides, we're going to consider two important terms we'll be using all year: construct and operational definitions. A construct is an abstraction or a concept. And we're interested in many constructs in psychology, such as anxiety, quality of life, extroversion, intellectual functioning, achievement motivation. These concepts or constructs are frequently a focus of clinical work and of research. Constructs are equally important in organizational or educational settings, and in those settings we'll frequently discuss concepts such as leadership, performance, ability, or aptitude. When we speak of a construct, we are often using or implying a conceptual definition of the term. An operational definition takes the construct and its conceptual definition to the next level by specifying the rules by which we will agree to measure or to detect a construct in a particular context. So, for example, full-scale IQ scores from the Wechsler Adult Intelligence Scale 3, the WAIS 3, are often used in research and clinical settings as operational definitions of the concept intelligence. In statistics, we will be focused on operational definitions primarily. The key to an operational definition is that it is expressed in terms that can be observed and measured by others, and that it is context specific. By context specific, I mean that the operational definition must be specified and made known to all in each setting in which it is used. For example, scores on the Beck Depression Inventory are frequently used to operationally define depression in both research and clinical applications. And we've been using it in the example we have been following so far in this class. However, we could go from one research article in a journal in which depression is operationally defined by scores on the Beck Depression Inventory to another research article in the same journal in which depression was operationally defined by scores on the depression subscale of the MMPI-2 or on the basis of a clinical interview. Thus, the operational definition is observable by all, for example, scores, and it is specific to a situation or an application. In an empirical study, we must operationally define both the independent and dependent variables. In the study example we've been using in this series of lectures, the independent variable, type of treatment, is the construct. It is operationally defined by the categories treatment and control. And the dependent variable, depression, which is the construct, is operationally defined by scores on the Beck Depression Inventory. To think further about the context of this study, the independent variable, type of treatment, could have been operationally defined in many other ways. For example, we could have compared our treatment of interest against a standard treatment control group already available in the community, as well as comparing the treatment to a no treatment control group. So in this example, the independent variable would be a between subjects independent variable with 3 levels. Studies are conducted to address research questions and research hypotheses. A research question is a query about the nature of the differences between groups or the nature of the correlation between two variables. For example, in the study we have been discussing, we might ask, is there a difference in depression between depressed individuals who participate in the new experimental treatment and those who don't? In another example, we might ask, is there a correlation between the levels of stress experienced by adults and their life satisfaction? Both of these are research questions. A research hypothesis takes the research question to the next step by predicting the expected nature of the difference between groups or the expected nature of the correlation between variables. So in the study we are following in the class, we might hypothesize that the treatment group will have lower depression, actually lower Beck Depression Inventory scores, than the control group at the end of treatment. Similarly, we might hypothesize that there is a significant negative relationship between stress and life satisfaction, meaning that as scores on a measure of stress go up, scores on a measure of life satisfaction will be hypothesized to go down. Hypotheses are tested and confirmed or not confirmed based on the observations of the operational definitions of the independent and dependent variables. In this slide, we will discuss the meaning of the terms population and samples. A population is a collection of persons or units or objects about who we wish to draw conclusions, make inferences, or reach decisions. It's the entity about which we want to make inferences. A population can be any size. It really depends who we hope to ultimately be able to refer to. For example, if I were interested in drawing conclusions about students in this class, then this class would be a population. So a population is context specific and depends on the intent of the researchers. This semester you will hear me say the population of interest, and by that I mean the intended population of the researcher about whom he or she is hoping to make inferences. It is very important not to confuse the technical use of the term population with its common usage. In the former, we mean a specific group of individuals sharing some important characteristic we hope to make inferences about. In the popular use of the term, we might refer to the population of a city or of a state. Finally, a population doesn't have to be comprised by people. Although research in psychology is generally interested in populations of humans, economic research may focus on sales receipts or earnings, and agricultural research may focus on populations of farming land or herds of cattle. A sample is a subset of a population that is assembled or selected through some method in order to stand in for or represent the population. In this final slide, we want to understand the meaning of both a parameter and a statistic. A parameter refers to the numerical characteristics of a population and is represented by symbols from the Greek alphabet. For example, the Greek symbol mu is used to represent or refer to the mean of a population. Statistics are the numerical characteristics of a sample, and we'll use English letter alphabet to represent sample statistics. So M is used to refer to the mean of a sample. An important concept we'll be working with throughout this semester is that we compute sample statistics in order to estimate the population parameters. Thus, M is used to estimate mu. Similarly, the sample variance, S squared, will be used to estimate the population variance, or sigma squared. Also, the sample standard deviation, S, will be used to estimate the population standard deviation, or sigma. And the correlation coefficient in the sample, R, which is called R, will be used to estimate the population parameter, which is symbolized by the Greek symbol rho. Note that this last symbol is called rho and is the Greek alphabet or analog to our R. It is not a P. One way to become more familiar with the Greek alphabet is to turn on the symbol font of your word processor and then type out the alphabet.